Okay. Arij asks, I'm just wondering what will be tested on, whether we'll be tested on the guest speaker content. I know we covered that in the first meeting, but I'm confused about it. So as I mentioned in the first lecture, what we'll be taking from those lectures would be, you know, they just give you an additional kind of breadth of seeing different types of data, seeing different types of questions that are asked using data. And so, you know, I may take an example from that. I will not, you know, again, I'm not going to ask you to memorize content from those lectures, but what I might do is borrow an example from it and ask you to, you know, ask some questions about, you know, a figure or something like that from one of those lectures. And I'd give you the backdrop necessary to interpret it. So it's really helpful to view those lectures, but I'm not, you know, it's not as though I'm going to ask you to memorize content in those lectures. Does that help, Arish? Okay. The next question is, can you go over atmospheric circulation again with polar feral, etc.? Yeah, I can sure do that. So let me just get the right. I'm not going to be able to draw through it for you like I did in the lecture, but you can always go back and watch that again if you want that explained to you again. Okay, so I am going to hang on here, slideshow, set up slideshow. Yeah, okay. Okay, so I'm going to pop this into full screen and I am going to share my screen with you. Okay, can everyone see that? Hopefully that's a yes. My chat has disappeared. Yeah, okay, great. Yeah. I have my chat back. Oh, thank you. Yeah, please turn on your mic and just talk to me if I'm missing something. Okay, so we have our tropical heating here. So here we are at the equator. So if you remember from that diagram that I drew on the whiteboard in my basement, you've got the Earth, you've got the equator in the middle. Here we are at the equator, so 0 degrees latitude. Now the equator has a lot of incoming solar radiation. So air at the equator is very warm. If anyone has been to the equatorial tropics, it is warm all the time. It is lovely. I'm a bit of a cold person, so these warm temperatures there are just delightful. So it's very warm air, and the issue is that warm air rises. And so we have warm air rising up. As it rises up, it cools down. And so this is what forms this bank of clouds at or around the equator. And if you recall, we talked about that intertropical convergence zone that shifts around. So this bank of clouds is basically that. And depending on where we are in our rotation around the sun, that bank of clouds shifts a little to the north or a little to the south, which drives that seasonality and precipitation in dry tropical forests that we had in the lecture from yesterday. Okay, so you've got warm air, it rises up here at the equator, forms clouds, and so you have a lot of precipitation at the equator. This is why we have that, you know, we've got warm, wet conditions there. That comes up here, this line that you can see here, this is the top of the troposphere or the tropopause. And so the warm air rises up to the top of the troposphere or to the tropopause, and then cycles around. And now it's dry air. That moisture has been removed as it came up. It's dry air, it cycles back around, and then it drops down. And it drops down at the tropics of Cancer and Capricorn, depending on whether you're in the north or the northern or southern hemisphere. Okay, so we have this area of low pressure here because the air is rising up away from the equator. So the air is moving up, so it's low pressure, and low pressure areas are places that tend to have lots of clouds, lots of precipitation. So when you hear, oh, low pressure system is moving in over Ontario, that's when we're going to get precipitation, right? And so in general terms, those low and high pressure systems vary from, you know, with changes in the weather and that sort of thing. But in general terms, across the globe, the equator has this low pressure system that is there, you know, all the time. And then over here around 30 degrees north and 30 degrees south, where that Hadley cell comes back down, it's bringing down dry air, and the air is coming back down to the Earth's surface. You have this area of high pressure. So that corresponds with areas of clear, you know, clear conditions, sunny skies, etc. So this is, so then the air that's moving up here because hot air rises has to be replaced by something. So this drier air that comes down here flows along the land surface, picking up moisture as it goes, and returns here to the equator and then cycles back up. So those are those convective cells that are formed. Okay, does that make sense? Is that this is helping me to understand much better. Okay, you think you're okay? Does anyone want me to keep going? Could you explain why the Coriolis effect changes the direction of the wind across the tropics of Cancer and Capricorn? Yes, I can. And I might even post an extra. I found a super cool way of demonstrating it that I might do with my kids when they have some time, and I'll post that to demonstrate how that works. It's a really simple, neat visualization of that. Okay, so is everybody good with the circulation cells? And then if we just to sort of speed through this, the same thing happens at the poles. So you've got this polar cell that's formed because you have warm air here rising up, cold air dropping down at the poles, coming it back across the landscape, and it warms up and rises up. Okay, and then that feral cell is kind of forced into being with this warm air rising at around 60 degrees north, and this dry air coming down around 30 degrees north latitude. And so you have this feral cell set up. So you have these alternating places of low pressure, high pressure, low pressure, high pressure, okay? And those patterns of low and high pressure are those kind of bands of low and high pressure are really important for wind movement on the planet. And that's where the Coriolis effect comes into play. Okay, so let's just take a look at this figure. So if you think about this area here, this is not the best diagram to demonstrate that actually, but we've got an area of high pressure, an area of low pressure. So high pressure around the tropics of Cancer and Capricorn, low pressure around the equator. And so air moves from areas of high pressure to areas of low pressure. So you have movement in the northern hemisphere. You'll have movement of air from the north, from 30 degrees down to 0. And in the southern hemisphere, you'll have movement of air from this band of high pressure at 30 degrees south, northward toward the equator. Okay, so this is where these lines are coming from in this diagram. All right, so this is just kind of, oh, this is actually a terrible depiction of that. Sorry. This is a really bad drawing of that. Okay. So I'm going to shift over here. We also have the Earth turning all the time, and it turns in this direction, right? So you can see the direction of the Earth's rotation here. Of course, here, oh, you guys can't see where I'm pointing with my finger. Of course, here we are in North America. You know, the sun rises in the east and it sets in the west. And so, of course, we know that this is the direction of the Earth's rotation. So we turn around this way, the sun rises, then we keep turning, and sun sets in the west. Okay, so because the Earth is turning all the time, you have air that starts here, but it's moving starts here in this area of high pressure, it's moving toward this area of low pressure. And because the Earth is turning in this direction, the air gets displaced to the right in the southern hemisphere. So you can imagine if you were, I keep trying to point to this. You can imagine if you were walking down here, your right would be over on this side. So this air gets displaced to the right because of the Earth turning. And in the southern hemisphere, same thing, air is moving in this direction, the Earth is turning, and the air gets displaced over to here. These winds get displaced to the left in the southern hemisphere, okay? Did that clarify things? Yeah, okay, great. Okay, now guest speaker, atmospheric circulation. I really like the definitions. Would you be able to explain Hadley Cell in a definition? Almost, I understand it like a pocket of air which cools and dries and reabsorbs. So if you watch the video that I posted, I think one of the nice analogies for any of these circulation cells is that analogy of boiling water, where you've got, you know, heat that causes the warm water to rise up, and then it cools as it's rising up, and then it drops back down. And you can see that happen. If you put some pepper or something into a pot of boiling water, you can see these convection cells form in that pot of boiling water if you have, you know, a glass pot or whatever. So I think that's a really good analogy. But we have warm air that's rising up, it's releasing moisture as it rises up, and then that cool, dry air drops back down. And so I don't know if that helps as a if that helps you, Haley. And there might be a formal definition in the back of the textbook. But what I really want you to understand, I'm not going to ask you to define a Hadley cell. What I really want you to understand is, you know, the links between these atmospheric circulation cells and precipitation and winds, and what that means for vegetation and the biomes we have been looking at. So, sorry, I'm having trouble getting to my H page. A Hadley cell. Okay, so here is the definition from your text of a Hadley cell. So there's a great glossary in the back of your text that you can go to for any of this stuff. A large-scale, three-dimensional pattern of atmospheric circulation in each hemisphere in which air is uplifted at the equator and subsides at 30 degrees north and south. So I don't know if that's helpful. I feel like some of those kind of analogies of how it works is probably a little bit more helpful, but that's the definition that's in the back of your text. Okay. Out of curiosity, will we always have 2 video lectures and 1 synchronous lecture per week, or do the videos vary from week to week? So this is going to depend if we have a guest speaker. So some weeks we have guest speakers, and those will be synchronous, and they may be in some of them are on Tuesday and some of them are on Thursday, and those are in our class schedule. So those weeks, we will still have probably what I'll do, because most of those speakers are only going to speak for half an hour. Probably what I'll do for those weeks is have our synchronous session after the guest speaker has given their lecture, and after we had a question and answer period. So then the guest speaker can leave, and we can have our synchronous session after that. And if we need a little bit more synchronous time, we can figure that out for that week. So typically, yeah, I'll be posting a couple of lectures. I'm going to try to have them, you know, in around 50 minutes, and then we'll have our synchronous session. So that would be this week, just walking through the biomes. I end up getting a little bit too chatty when I'm talking about those things. So that ended up being a little bit longer. Okay. I'm just wondering why week 2, lecture 2 is on YouTube. Is that not for today's class? So I produced 2 lectures this week, one on chapter 2 and one on chapter 3. And both of those are posted on YouTube, and the PowerPoint slides are in my learning space. And thanks for the reminders from folks to pop those slides into my learning space. You'll have both the original slides that I use for those presentations, as well as the lecture in my basement. Okay. Okay, so I have a question here. Can you explain how the Earth is furthest from the sun in July, but we experience summer and higher temperature at the same time? So it all has to do with the tilting of the Earth's, the fact that the Earth is tilted on its axis, and I imagine there's probably somewhere in here a picture. Yeah, here we go. So we have the rotation of the Earth around the sun, and the Earth is tilted on its axis at 23.5 degrees. And so in the equinox, when we talk about the equinox, equa is equal. So the equinox is the time of the year that both the southern and the northern hemisphere receive 12 hours of day and 12 hours of night, and the equator typically has about that all year round, okay? So that's our equinox. And then in the winter solstice, this is when the northern hemisphere is tilting away from the sun. And so our days get much shorter, our daylight periods get much shorter, and the angles of the sun are much, as they hit the northern hemisphere, are much kind of larger angles than, smaller angles than when we are either at the equinox or in the summer solstice. Okay, so we get these really kind of low angle light coming in that's very, very weak. And so we have kind of weak sunlight, so not a lot of energy in the sunlight, but also because the Earth is tilted away from the sun at that time of the year, because the northern hemisphere is tilted away from the sun at that time of year, we have our winter then. In contrast, at that same time of year, the southern hemisphere has their summer. And so right now, as we are in the midst of some of our shortest days and our coldest time of the year, Australia and New Zealand are enjoying their summer months. Now, in the summer solstice, so June 21st, this is our longest day of the year. And this is when we're tilted, the northern hemisphere is most tilted toward the sun. And when we get the most radiation throughout the day and the most kind of direct radiation. So the sun is much stronger at that time of year. And this is why everything becomes much more, this is why we have our spring and summer with plant productivity and the disappearance of snow and all of those sorts of things. Does that help you, Caitlin? Does that make sense?
Yeah, it does. Thank you.
Okay, awesome. Okay, when is the group 3-minute presentation due again? I will pop all those dates into the calendar, and I'll do that tomorrow. It's in the presentation from the Synchronous lecture last week, all of the deadlines, but I believe March 11th was the deadline that I indicated. I do want all of you to have your groups decided and have your topics refined by the end of this month, so January 31st. And one thing I wanted to touch on is I did take a look at the topics that folks were putting into that discussion, and I haven't responded to individual groups because I saw a general trend in the topics that were being proposed in that they were incredibly broad. So just, and this is not, this was very typical in terms of the breadth of the topics, but I think, I'm just thinking off the top of my head, there were a couple in there that one of them was parasitism, one of them was I think maybe mutualism. So these are incredibly broad topics, and this was typical of those two are just jumping to my fuzzy brain right now. But those were typical in the scope, and those are really, really big topics, right? And so what I really want you and your groups to work on is identifying. So any of those things are awesome, big, broad topics. The next step is to take it to refine those questions so that you get down to something that you can actually tackle reasonably in a 3 to 5 minute period, and ask a neat question about it, right? So if you recall the the last lecture that we had, and I'm just going to stop sharing my screen now. If you recall the last lecture that we had, I think the question that the Minute Earth people posed was, why do some animals eat their babies, right? So that's a very kind of focused question. And what I want you to do is you've identified a broad topic, and now I want you to hone in on that very specific question that you're going to be able to, dig into the literature a bit about, figure out a neat storyline to tell with that, to identify, to answer the question that you're going to pose, and to be able to bring in some, some interesting examples to demonstrate that story as you're moving through. I think it probably would be, yeah. So does that, I hope that is clear to everyone, really working to refine the move from something that's really broad to a really specific question. And a number of people stopped into to student hours, I should say, to talk about their topics. And I'm really happy to talk about those with folks during that time. And so once you have your groups coalesced, just, feel free to come along to student hours on Tuesday, and we can talk about topics at that point in time. Okay. If we weren't able to find a group, will a group be chosen for us? So there is a discussion, a chat in the discussion forum for you to identify a group. If you are still not able to do that, using that chat, I can help, but there's lots and lots of posts on there, and different different people finding each other in that chat. So I'd really encourage you to do that independently if you are able to. And if not, then I'm happy to help facilitate that. But yeah, the discussion chat should help. Okay. Any other questions at this point? Okay, I'm not hearing anything else. One thing I did want to highlight for you, I'm not sure if all of you have had the chance to explore Google Earth, but from the perspective of the topic that we've been covering in this past week in terms of different biomes, it's a super cool way to be able to explore some of these biomes, look at the structure. There's even, people have gone out and even done these, really kind of incredible Google Street View walks through different places. So you can actually take hikes through different ecosystems and check these places out that way. And I've just been exploring it a little bit because, I had planned on, had we been in person, I'd planned on kind of thinking about an in-person, activity that we could do in class, which didn't really pan out given that we're not in person. But I just, just as an example of the kinds of things you can look at in Google Earth, I'm just going to share my screen because I thought this one was particularly neat because it really links those patterns of climate with species distribution information. I'm just going to share with you this and just turn it on here. So this is a little feature in Google Earth, or something in Google Earth called Tracking the Rainbird. And this is a pied cuckoo. And we have here India. And the really neat thing that we can watch here, so you can kind of go through these different pieces. So it gives you a little bit of information about the South Asian monsoon. So monsoon being, in these seasonally dry environments, the monsoon season is when all of that rain happens. So if you remember our lecture on, or the part of the lecture where I talked about seasonally dry forests, and even into savanna ecosystems, you have this really narrow window of the year where a huge amount of precipitation falls. And anyway, that's what a monsoon is. And so you have, part of the year where the whole system is bone dry and you don't get any precipitation, and then part of the year where the monsoon starts to move in. And I believe this shows us the monsoon, so we can go to June 1st. It takes us out a little here. So this is May 1st. You can see that there's almost no precipitation. It's just really starting. Here's the scale of daily rainfall here. So very little. We go to June 1st, and that whole system is starting to move in over South Asia. And then you can see we have this really intense heavy rainfall, up to 20 millimeters per day in July. And the neat thing, so then it tells you a little bit about this legend of Shataka, or the rain bird. It's the Pied Cuckoo. And they show, so this is super neat. You've got the monsoon happening, and it shows the expansion of the distribution of the Pied Cuckoo in response to precipitation. And so they have all of these collared animals that they monitor their, where they are in the dry season, where they are, and their movement in the wet season. And so you can see these birds expanding as this monsoon comes in and habitat becomes more available. So they stay in the southern tip of India when it's in the dry season. So they stay in the wettest part, and then they expand northward as the monsoonal rains come in. So I just wanted to give this example of some of the really neat things you can look at in Google Earth. There's also, you can just zoom into any system and go and take a look at what the structure of the canopy looks like. There's all kinds of amazing information about, conservation initiatives that are happening in different areas, wildlife and their response to different, like we saw here with the Pied Cuckoo example. So anyway, it's a really neat tool to explore, and be able to actually, even though we can't go to these places in person right now, being able to kind of explore videos and panoramic shots that other people have taken in these systems, and kind of get a better handle on what some of these different parts of the world look like. Okay. Okay, so a few more questions for the midterm. Will we be getting any practice example questions of the type of question we can expect for it? Yeah, sure, I'm happy to do that. I typically do provide example questions in advance of midterms, and we can even use a synchronous session to kind of go through the answers for those, if that would be a helpful tool for you folks. That would be amazing. Good. Then I will make sure to make that happen. Could you explain the second set of questions of the online assignment? I watched the portion explaining the graphing last week, but I'm still confused. So are people having trouble with the graphing, or having trouble with the interpretation of the graphs? Can I get a little clarity on that? Both, haha. Okay. Okay, so we can walk through the graphing again. Let me pull up. Yeah, so another question here for these graphs: are we finding the biome? So you basically have 4 options. And so what I tried to get across in that lecture that I gave yesterday, and that's why I gave some examples that were a bit different than your text in terms of the climate diagrams, because in your text there's only there's a single climate diagram that represents that biome. And so I tried to give some examples to show you that, how variable these climate diagrams can be. Yeah, and so Trevor says the second lecture this week will help you with understanding what the graphs show. Yeah, so I walked through those climate diagrams and also, yeah, went through a number of examples from different systems to demonstrate that, they're very, the climate diagrams are variable. And so what your job is to plot up those climate diagrams, and I'll get to that Excel spreadsheet and walk through that again in just a second. But what your job is to plot up your climate diagram and, using help from your text and the answers that are available, find the biome that best matches the climate diagram data, the climate data that you have and the climate diagram that you produce. Okay. You're not going to get a mock midterm. Sorry, I'm just seeing questions pop up here. I'm not going to give you a mock midterm. I'll give you some questions that we can work through that will be similar to what you'll have on the midterm. And yeah, the answers I'll post the answers once you have had a chance to work through some of those. I'll post the answers and we'll work through those answers in the synchronous session before the midterm, which I'll have to figure out when that is, sometime in February, which is not too far out. Yes, this recording will be posted. Okay, I'm going to open Excel. I have too many things open in Excel right now. It would turn out, not fun things, just budgets. Let's see here. Okay, there's my synchronous lecture example. Okay. So I'm going to delete a couple of graphs and we can just walk through this. So I'm going to share my Excel worksheet and you guys should all be able to see that now. Okay, so these are the data that are in that assignment that you were provided on My Learning Space. And I've changed, of course, as I went through last week, we've changed the formatting of that. So the way those data were entered into that table was in, you had a particular site and temperature or precipitation and then months along the top. And that's not very useful for plotting. And so we've sort of turned it on its head. We have month now here in this A column, and we have temperature for Zaragoza and precipitation for Zaragoza here. These are just kind of turned on their head from that set of data. And temperature for, I can't remember what BL stands for, Big Lake, and precipitation for Big Lake, and then temperature and precipitation for S. I can't remember what S stands for. Anyway, the third spot. So the way you can plot that, and so if you remember, what we want to do is put precipitation and temperature onto a graph together with month on the x-axis, and here my month is just plotted up as numbers, so 1 being January and 12 being December. You could make this fancier, but you're not submitting the graphs, and so you don't necessarily need to make it fancier. The thing you have to remember when you're plotting these up is that for us to be able to interpret whether or not there's sufficient precipitation in a particular month to meet the evapotranspirative demands of the system, we have to make, we have to modify the graph so that, 1 degree temperature, 1 degree Celsius in temperature is equivalent on the opposite axis to 2 millimeters of precipitation. And so this is a sort of rough approximation of when there's a sufficient precipitation coming into the system to meet the evaporation and transpiration leaving the system. Okay, so here we have this made up already for Zaragoza, and so we can just kind of walk through this, and then I'll show you how to make those graphs again. And so our blue line in this case is our temperature, and so I think this is opposite to what is in your textbook, but the orange line is precipitation. And so we have this nice kind of increase in temperature. So some seasonality in temperature going from about 15 to about 30 degrees. So pretty warm place, right? There's no month there's no point in the year where temperatures drop below freezing. So a warm place. And then in terms of precipitation, we see that there are sort of extended periods through the year that have insufficient precipitation to meet evapotranspirative demands, but chunks of the year where precipitation is sufficient to meet evapotranspirative demands. So this is the kind of figure that we have to interpret, and then take a look through the text, take a look through the lectures, the lecture slides, and say, okay, well, and you can also, take a look at, you can calculate average temperatures, average precipitation. These are all clues to give you a sense of what type of biome this might be. But in the answers that I've given you, there's only one answer that is, sometimes they're not, sometimes they're not like screaming out to you, oh yes, this is absolutely, tropical rainforest. But there will only be one answer in that list of answers that is a reasonably good match to the data. So in this case, for example, if our temperature was up a little bit higher and we didn't have any month where precipitation exceeded temperature, or if our precipitation was a little lower, we'd be in a situation where we had a desert ecosystem, right? But we do have months where precipitation is greater than evapotranspirative demand. And so we're into some other fairly dry system. And so using those kinds of clues to help you work through that. So let's plot up another one. Let's do, I remember the name of this, so we'll do this one, whatever S stands for. And so you highlight all three columns of data. And so because we want to make a graph that has two axes, we're going to go up here, and I'm using a Mac. So this may be a little bit different for PCs, but it shouldn't be too much different. Excel is Excel. So you go into insert, and there's all these different chart types. And there's this one here that is combo charts, okay? And so using two different response variables on the same plot. And so I'm gonna do this one here that has a second, it shows this dotted line. So line on secondary axis, that's exactly what we want. And so we can select that one, and it creates this graph like this. I hope everyone's seeing this. Okay, so a first step that we have to do is take a look at our axes. So our precipitation axis goes from 0 to 30. Our temperature axis goes from 0 to 80. And so we need to change this. And we can either leave these bars as bars, or we can change them to lines. I'm just going to leave them as bars here because it doesn't really matter. You're going to be able to tell if your precipitation in that month is exceeding your temperature. Sorry, if your precipitation, the orange line, is exceeding your temperature. So to make these match, all I'm going to do, because our top value here is 80, we want this top value to be 40. So it doesn't always need to be 0 to 100. It's just the numbers on the top. Temperature needs to be half of precipitation so that we can directly compare the data that are in our graph, okay? And so I'm going to format this axis. And I'm just going to change this. So you'll get a little box like this that pops up. So all I did to format the axis was Control, and I controlled and clicked on this. I think if you had a mouse that wasn't, I'm using a touchpad. I think if you had a mouse that had 2 clicks, you could probably just do a left click and it would do the same thing. And I'm not sure what the button is you press on a PC to make that happen, but you will know if you are a PC user. So I'm changing this to 40. And pressing enter. And so now we have this diagram where we've got our temperature plotted up in blue. We have our months down here on the x-axis. We have our temperature on the first y-axis. We have our precipitation on the second y-axis. Does anyone want to walk through interpreting this? Like, anyone can jump in and sort of walk through what they're seeing. Any volunteers? Oh, you're a quiet bunch tonight.
There's an above average amount of precipitation compared to the temperature.
Well, so yeah, I instead of above average, I would use the words there's sufficient precipitation to meet evapotranspirative demands. But yeah, absolutely, your precipitation is in excess of what's needed to meet those evapotranspirative demands driven by the temperature in the system. Okay, so most months, I guess all months, we have enough precipitation to meet temperature demands. And so then you have this graph, and this is for S, whatever S stands for, and you're going to go to your text. You're going to go to the descriptions of these different climate diagrams. You can listen to my lengthy descriptions of these different climate diagrams on the lecture, and you're going to figure out, okay, well, which of the biomes does this match up to? Okay, so you have 4 options in the quiz that's associated with the questions, and so you use this graph to answer those questions. Hold on to your graphs, because if you get something wrong, then you and I can sit down and go through what went wrong, so you don't either interpret something wrong on the midterm or whatever it happens to be. So does that help the folks who were having trouble with this? Do you want me to go through another example just to repeat doing that? Would that be helpful to see those steps? Okay, I'm seeing exclamation points with yes. That means it's important. Okie dokie. So let's try our one that we haven't done. So I'll just move this over here with Zaragoza. So we highlight our month again, and we'll take temperature and precipitation. So what I'm doing to highlight, and sorry, where would we find examples of the different biomes? They're in the lecture and they're in the textbook. So I've taken the figures from the textbook. So in the textbook, they're in chapter 3. And you'll have the exact same pictures that I used in the lecture. So stuff like this that has a map of where they are and a climate diagram like this that you can actually take a look at. And then a description of, in the text, there's actually a verbal description of what those biomes are like, what the climate in those biomes are like, some of the challenges that those biomes face. So all the kind of stuff I went through in that lecture. But for each biome, I have gone through these same figures that are taken from your text. And in some cases, I've added some extra ones in because, especially in certain biomes, there's just a lot more variability in the kinds of conditions that you can, the kinds of climatic conditions that you can have. So I've borrowed from a different ecology textbook, the Moles and Cahill ecology textbook, where they have some variation in what those climate diagrams look like. Okay, so for those of you not familiar with Excel, the other thing to note is what I'm pressing on my keyboard to highlight multiple, and I know we have a range of expertise in this. What I'm highlighting on my keyboard that to skip over to this. So we highlight A, and then we want to highlight D and E together. I'm pressing the command button on my Mac keyboard. So you'll know, like you may have to, if you're not familiar with Excel. If you are familiar with Excel, you'll already know how to do this. If you aren't familiar with Excel and you're not a Mac user, oh, and Trevor's saying control for PC. So it's command for Mac and it's control for PC. So that's how you do that on a PC. And that lets you skip over some columns and highlight columns away from it. Because if you just try to drag it across, what will happen is this, and that's no good. You don't want to plot all of those things together. So in a Mac, you're pressing command. In a PC, you're pressing control, and then you highlight those columns that you want to use. Okay, and then we go back up to our insert menu, and we get our graphs again. So the place you find your graphs in Excel is under insert. And we go back over here to this cute little diagram. That's our combo. I wonder if someone who has a PC, once I'm done, if someone who has a PC could just show the same thing on their PC in case there's any differences between the Mac Excel interface and the PC interface. just for those folks who are unfamiliar but maybe are using a PC. Okay, so we go to combo. And we want the one that has that really faint dashed line here as our second axis. We want those two axes. So we click on that and it's going to make our nice graph again. We'll just leave it as bars again. I'm going to make this bigger. So we have our temperature in the blue bars. We have our precipitation in the orange line. And we look at this and our precipitation range goes all the way to 100. So again, we want our temperature, 1 degree Celsius temperature to be equivalent to 2 millimeters of precipitation. Right now, that's not the case. So we go over here, press Control and highlight that axis. Is it also Control on PCs, or is it a different button to highlight the axis on PCs? That'll pop up in the chat, I'm sure. So format our axis, and Trevor says it's Control. Thanks, Trevor. Format our axis. And we put in, because we're at 100 over here, we want this to be half of that. So we're going to put in 50. Okay. And so we have this situation where we have, a cooler climate than was the case for Zaragoza, where we had, a minimum of 15, a maximum of about 30. Here we have a minimum of 7 or so, and a maximum of about 25. So it's still a pretty warm place. And in this case, there's more months. So this is a wetter place, so a little bit cooler, and a little bit wetter, more months where we have precipitation exceeding that evapotranspirative demand, or kind of right on the border of meeting it, right? So we have some months where there's not enough, and then other months where we have ample precipitation. So it's or double click on the edge of the axis. Yeah, that's great. So definitely not as wet as oh gosh, that didn't work. Undo that. I'm just going to move this one up here and move this one up here. Definitely not as this site doesn't have as precipitation in excess as to the same degree as our whatever the S site was, but Big Lake. I'm gonna title this Big Lake. But Big Lake has more excess precipitation through more of the year than does Zaragoza. That doesn't necessarily mean they're different biomes, because again, when you go through the lecture, you'll see that different biomes can have, can occur in places that have, or if you take a look at, for example, figure 3.4 in your text, there can be a pretty wide range of variation in either temperature or precipitation, or both, within a biome. And so you can have different combinations of these. And so what your goal is here is to figure out the best match to, once you get your graphs put together, the best match from a biome perspective for that. Okay, does that help? Is that a useful conclusion to that? Or are there more questions about Excel and doing this? Okay, I'm seeing yes, thank you. Great, I'm going to stop sharing at this point. Okay, a question here. In chapter 3 of the textbook, there was a section on aquatic biomes, but I didn't go over these. No, you can feel free to read through that material. I would encourage you to. The fact of the matter is that I can't cover everything in the text. And so I really felt like it was important to cover off on the links between climate and these broad scale biomes and how those are connected, but I am not going to get into those aquatic ecosystem, the details of, different zones in water bodies as part of this course. There are certainly other courses you can take that will get you into all of those kinds of details, but that's not something I'm covering in this course. So if I don't cover it in the lecture, but it's in the chapter, you don't need to cover it. So if it would be helpful, I can try to modify the syllabus so I actually indicate the page ranges, but I think based on what I'm seeing in the, based on your question, you're recognizing that I didn't cover it in a lecture. And so it doesn't need to be, you don't need to study it as part of, midterm preparation. But certainly from an interest perspective, feel free to read through it. It's everything in here is useful from an ecology perspective, but the problem is we could cover, to cover this whole book thoroughly, we would need to have a year-long course. Other questions?
Sorry to interrupt, Dr. Baltez. Just like
that's great.
Just said, you said you could modify the syllabus and add the little like topics, if you
like
will.
The page ranges.
Yeah. Would it be more convenient for if you would just like before like our midterms and our exams? Would it be just more? Because I understand, if you just watch the lecture and the stuff you went over is the important stuff. Would it be still more convenient instead of you going in modifying this syllabus to just post an announcement on My Learning Space with just
what I'm
little
going to do?
titles?
That's a great idea, Vasvi. But what I'm going to do, and I hope I said your name right. What I'm going to do is in the description of each week's information, I'll just put the page ranges of what I covered in the lectures for each chapter. Does that sound good to everybody? And then there's no confusion about what you need to cover or what you don't need to cover. But do feel free, if you've got some spare time on your hands, then feel free to read through sections we aren't covering. But
thank you.
Okay, you're welcome. Thanks for the input there. Yes, modifying the syllabus is a little bit of a pain, and I know those documents are long and kind of unwieldy to work with. So anything else at this point? Okay, so if there aren't any more questions, I'm going to leave it at that.